Wow, okay people, just look at the background there. What we've got is North Derbyshire, and it's absolutely beautiful up there. Right, let's just grab one of these. This is section 2 on the higher paper, and specifically section 2.1 dealing with the nth term of a sequence. In other words, the rule for a sequence. Before we do all that, let's do a very, very basic one. It says find the term-to-term rule for the following sequences. It's very easy, so this is only grade D if that. So 0, 3, 6, 9. Well, term-to-term means doing, 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 add 3. That's all it is. Okay. So this is all about adding 3. Next one, I've got 3, 7, 11, 15. As you can see, it's going up in 4s. So the term-to-term sequence is keep adding 4. What about this one? Go up here. I've got 25. Then I've got 20. Then I've got 15, and I've got 10, etc., etc. Clearly, we're subtracting 5 each time. So the rule is subtract. Alright, subtract 5. That's term-to-term rules. Now here's a nice little one. I'll put it down here because I've got all these hills in the way. I've got 0.01, I've got 0.1, got 1, and I've got 10. Well, look very carefully. I'm multiplying by 10. 0.1 times 10 is 1, and 1 times 10 is clearly 10. So the rule for the sequence is, as a term-to-term sequence, that means going from one sequence from the left to the right, it's multiplied by 10. Alright, that's that one. Turn another page, I think. It says, question 3, write down the first 5 terms of the sequence whose nth term is, let's do an easy one, 5n minus 3. That's the nth term. Alright, put it down here. So for example, if I wanted to work out the 10th term, I'll just simply go 5 times 10, 50, take away 3, 47. So the 50th term would have an answer of 47 attached to it. That's it. It says write down the first 5 terms. Well, the first 5 terms is where n is worth 1. So 5 lots of 1 take away 3, it's going to be 2. The second term, 5 lots of 2 take away 3. 10 take away 3 is 7. Next one, 5 lots of 3 take away 3. Well, that's going to be 15 take away 3 is 12. Let's work down here, maybe up here actually. 5 lots of 4 for the 4th term, take away 3, 20 take away 3, 17, and the last one, for the 5th term, 5 lots of 5 is 25, take away 3, 22, and that is the sequence of answers for the 1st, 2nd, 3rd, 4th and 5th terms. That's it, 1st, 2nd, 3rd, 4th and 5th. Now finding the nth term of the sequence is me giving you these answers here in a line and then working backwards to get the original sequence, the original nth term for the sequence. Let's do another one. 4n squared. Got to find the first 5 terms. So I've got 4 times 1 squared. Well, that's going to be 1 squared is 1. 4 ones are 4. Next one. 4 times 2 squared. Watch out for your Bidmas knowledge. Square it first, then multiply by 4. Not multiply by 4 and then square it. That's wrong. So 2 squared is 4. 4 4s are 16. Third term, 4 times 3 squared. Well, 3 squared is 9. 4 9s are 30. What's that? 2 18s, 36. Next one, 4 times 4 squared. Well, that's 4 16s, 64. And finally, 4 times 5 squared. 25 times 4 is going to be 100. And that's it. I think that's right. Yeah. So that's that. There's other dodgy ones that look a bit like this. N over n plus 11. It's not difficult. You merely substitute 1 in each, 2 in each, 3 in each, etc. So let me start you off. 1 over 1 plus 11. That's going to be 1 over 12. Leave it like that. Next one. It's going to be 2 over 2 plus 11. That's going to be 2 over 13. Good enough. Next one. 3 over 3 plus 11. That's going to be 3 over 14. And I'm sure you can see the sequence unfolding. Look, 1, 2, 3. for the numerator, 12, 13, 14 for the denominator. So that'll just continue all the way up to the fifth term. Alright, next page. You can get sequences using patterns that have been drawn for you, like in question 6, which I'm so not going to do. That's boring. I want to jump into doing the nth term for properly now. Honestly, for properly, but I'm going to do it. Here we go. Question 7, grade C. Write down the nth term in the following sequences. I think I'll do, I don't know, I fancy B. 0, 5, 10, 15. Well, that's the first term, second term, third term, fourth term, and the nth term is, well, we don't know yet. So that just continues towards infinity. Right then, from 0 to 5, add 5. From 5 to 10, add 5. And from 10 to 15, adding 5. So straight away, we have a 5n rule. I have to go black on that. We have a 5n rule. So then what you do, you work backwards to find the 0 term. In other words, what number goes there? And the question is, what number, when you add 5, becomes 0? Answer, minus 5, because minus 5 plus 5 becomes 0. So you have 5n take away 5 as the nth term rule. Okay, let's just test it with 4. If n is worth 4, I've got 5 times 4 is 20. 20 take away 5, 15. That works. Try it again. Let's work with the 3. 5 times 3 is 15. Take away 5 is 10. That also works. Therefore, I'm pretty convinced that the nth term for that sequence is 5n minus 5.